Hey guys, the second leading cause of species decline worldwide, second only to the destruction of habitat, is of course introduced species. Introduced species are plants and animals and other living things that have been introduced intentionally or by accident to a place where they have not lived before. Now, to be fair, most of these introductions are harmless. In fact, many are beneficial. 98% of the food that we eat in the United States has come from introduced species. But it's a bit like playing Russian roulette or sort of a biologic roulette, because occasionally some of these species can cause utter destruction and trigger ecological disruptions. Some can cause human health problems, and others can actually lead to great economic losses. And the reason why these can actually become such a problem is because they're leaving their home environment, but they're not just leaving their home, they're leaving their natural predators and their natural competitors. So when they're introduced into a new location, they can oftentimes outcompete native species, and they have no natural biologic control to their population. So their numbers can swell and cause major issues. Two examples include the cane toad and the gypsy moth. The cane toad is a classic example of a deliberate introduction that went terribly wrong, and the gypsy moth is an accidental introduction that changed the composition of the forest in the northeast United States. We'll look at both of these examples in the near future. Today I want to look at zebra mussels. This is something that hits close to home. And of course, zebra mussels are freshwater mussels or mollusks. They're about the size of a fingernail. And unfortunately, I'm sure many of you have had the experience of running into these D-shaped shells, which are incredibly sharp and can often cut your feet. In their larval form, they're mobile, but as soon as they settle onto a substrate, their abyssal threads attach themselves very tightly. They're filter feeders, so they derive nourishment by siphoning the water and all the nutrients and algae within that water. Their lifespan is about 4 to 5 years. Females reproduce usually after 8 months and many times. In one reproductive cycle, the female has 40,000 eggs. That usually equals 1 million per year. So to say they are our strategists would be an understatement. In fact, many introduced species are successful because of their R strategy. When they get to a new environment, they quickly repopulate. They are prolific reproducers and can quickly outcompete the native populations. The zebra mussel came from Eurasia, from the Black and Caspian Sea region, which is thought to be the point of origin. And the way it sort of hopped the pond is it hitchhiked. Massive ocean-going vessels, huge cargo boats, usually fill their hulls up with what we call ballast water. Ballast water is used to create buoyancy for the boat, especially when it has cargo on it. So by pulling up a lot of the water in the Caspian Sea, it also pulled up microorganisms, including the larvae of the zebra mussel. In this way, that massive ocean-going vessel hopped the Atlantic Ocean and moved up the St. Lawrence Seaway, where it then got to Lake St. Clair, a body of water nestled in between the Great Lakes of Lake Huron and Lake Erie. Once it got to the port of call, it dumped the bilge water or the ballast water. And of course, in that water, it was teeming with life, including the newly introduced zebra mussel. This happened in 1988, or at least this is when we first observed it. And as you can see, in a short time, from 1988 to 2000, it utilized the Mississippi River system as a conduit or a pathway for distribution. And it quickly spread itself very quickly throughout the Mississippi River system. You'll notice that it's mostly restricted to the east, And that has to do with the fact that most of the surface water in the United States is found in the East Coast. Furthermore, we have the greatest population densities along the east, and it is humans that have caused the spread. Finally, of course, the Rocky Mountains provide sort of a natural barrier for the zebra mussels and prevent them from getting to the west coast. But many argue it's not a question of if, it's when they will finally get there. What's interesting is how they actually went from the Great Lakes to some of these landlocked bodies of water. For example, how did it go from Lake Ontario to Canandaigua Lake? And that has to do with human activity. Humans, for example, could go fishing in Lake Ontario in the morning, and zebra mussels could attach themselves to the hull of the boat, or attach themselves to the anchor, or in this case, the propeller. Now, these zebra mussels, they're classic generalists. They have incredible range of tolerance. They can survive out of water for over 7 days in the right temperature and humidity conditions. So, existing in these conditions, perhaps sitting in someone's driveway, so after about a week of sitting in the boat owner's driveway, if that boat owner then decides to take their boat to Canandaigua Lake the following weekend, they could actually accidentally transport the mussels into that new body of water. Lots of other mechanisms. We could certainly talk about floodwaters spilling over, delivering the zebra mussels into adjacent bodies of water, opening up canals, and animal vectors are also agents of transport. So what are the consequences? For many recreation enthusiasts and tourism, they've perceived the zebra mussel problem as not a problem at all. In fact, a lot of our Finger Lakes improved in water clarity, and people like to swim in clear water. The problem with that is that the zebra mussels, by filter feeding, are decreasing the turbidity of the water, making it less murky, but they're also undermining the base of the food chain because they're filter feeding at such great numbers that they're removing the bacteria and the algae and the nutrients that are essential for producers and consumers in the ecosystem. Furthermore, since they are our strategists and generalists, they can outcompete very quickly the native population. And in fact, our native population of mussels and clams are quickly being taken over by zebra mussels, which are attaching themselves to our native population and virtually asphyxiating them. Our economy has taken a major toll. There's been estimated $1 million of destruction in sewage lines and clogged water pipes every year, for at least about $250 million annually. Absolutely amazing. So how do we actually prevent this? I think education is critical. If we're aware of what we're doing, hopefully we can prevent the spread. Prevention is far better than cleanup. We have yet to find a way to clean up these zebra mussels. So thorough inspection and cleaning of boats, perhaps considering where we spill the ballast water. In other words, if we were coming from the Caspian Sea, dumping that bilge water in the ocean prior to entering freshwater ports would be of the utmost importance. Refrain from building connective waterways. And there's been some technological solutions. For example, that bilge water, they've increased the concentration of nitrogen gas, which would decrease the dissolved oxygen and therefore kill the populations of the transported zebra mussels. Furthermore, they've also explored options for using ultraviolet radiation to kill that life in the ballast water, but that's pretty cost prohibitive. That's it for now, guys. We'll see you soon.